In the end of the third video, I mentioned that our copy assignment has certain bugs. Now we will see what those bugs are. Before we do that, we will run once again the code, but we will simplify significantly the main function. I will create one object of type credit card account, and that object will be called cat. We will set the name of this object to Mr. Watson, and we will add two transactions. Add charge. The first transaction is for $15.10, and the other transaction will be for $15.20, just as we did before. Now we will create another object that we will call dog. And this object dog first will be populated using the copy assignment. Dog equals cat, and we will now see what kind of memory diagram we obtain. So first we have cat, whose name is Mr. Watson, has balance of $30.30 after we added those two charges. Once we call the copy assignment, dog becomes equal to cat, so our dog as of now has the name Mr. Watson. So we are going to change that, and the dog will get a name, something different, so we will call the dog Poor Chug. The memory diagram now looks like this. Dog's name is changed to Poor Chug. We are going to run the code now. And in this running of the code, nothing will be printed. We are not even going to print the transactions. But this is going to be enough for us to see which methods get called with our functions. C++. So now output file will be called A. So we have two constructors that are executed. One constructor is for cat, another constructor is for dog, and then dog becomes cat, so which is observed here when copy assignment is called. Then this structure is first called for dog and then for cat. My first modification of the code that will show us the first bug is that instead of these two lines, credit card account dog and then dog equals cat, we will just do that in the same line. So essentially we are initializing dog to be equal to cat. And this is already going to result in a bug. And this bug is going to be different on different compilers. So the code will compile, but now when we run the code, something unpleasant will happen. We are seeing some, so this is CLang compiler. When this structure is called for Poor Chug, it results in very unpredictable behavior. And one significant thing that is worth noticing at the moment is that copy assignment was not triggered, because copy assignment would print the sentence copy assignment is called. This time we are not seeing that sentence. And the reason is that this copy assignment operator was actually not called, and when we have one line of code, cc account dog equals cat, actually it is not the same as the two lines of code, cc account dog and then dog equals cat. In this situation, what preprocessor does, even before the compiler is called, it replaces this line with the following line. So this line, compiler is not even seeing it this way. So what instead is being understood by the compiler is CC account of dog is, you are asking the computer, please give me sufficient memory for one credit card account. Let me call it dog and call a special constructor that has only one argument and whose argument is cat. So since we did not create that constructor, it's assumed that it will just copy the fields, and we get back to old problem that the head of the transactions, just the address was copied, not the entire stack. So now we will declare that copy constructor cc account So one argument is passed by reference and is of type cc account. We will now, a copy constructor must not have any return value. And our argument, we will call it in the implementation CF. CF stands for copy from. It is going to be essentially the same code as the copy assignment. But this is going to be called copy constructor. CName, we copy CF, CName, and the balance also gets copied. Address of the head of the transactions is copy stack from our argument. And now our code is going to run again. It's back to correct stage. Now we will see that copy constructor is called. I will also show you one more thing. So we will make these methods more informative in what they print. So when copy assignment is executed, we will just type copy assignment from, and I will now print the address of the object that we are assigning from. Assign from to, and now we will print the, so object assign from has one address. We are copying that object to another address, and that address is called this. So the keyword this contains the address of the object to which the operator is applied. Copy constructor will do similar printing from address of CF to this. And when this structure is called, we will also print the address. This. We will now execute our new code. So, when we create Mr. Watson, then Mr. Watson, I did one small, annoying, aesthetically very unpleasing mistake, so I should convert everything to integers, so we can look at integers instead of hexadecimal addresses. So sorry for that. I will clear everything and then recompile and run the code again. Oh, I have one more. This one will also be converted. And now finally. So the address of the cat is this number that ends in 12. The address of the dog ends with 56. So when we destroy the dog, we see the dog's name was Poor Chug. The destructor printed the address 56. When we destroyed Mr. Watson, then the destructor printed the address 12. I will now do some other. So the first bug is now created. We have to separate copy constructor from the copy assignment. Now our copy assignment has another bug. I will have the following code: dog equals cat. And then I will put the name again, because now the name becomes Mr. Watson, so I put it back to Poor Chug. And I will copy this code several times. 1, 2, 3, and maybe several times. So let's see what happens. Clear. I compile and then execute the code. So we are not seeing any mistakes, but there is a bug, and the bug can be seen once we analyze the memory diagram. So in our first copy assignment, we may want to have at our display in front of our eyes the assignment operator. Yes, so here is assignment operator on our screen and memory diagram. So when we call the copy assignment for the second time, we will copy the stack from the cat into a brand new position. So there is a memory leak, because this stack that the dog has from before will still be here. We are not destroying the stack. So now Poor Chug has a new stack, but if we call it again, then it's in another spot in RAM memory, and if we keep doing this, we are just destroying RAM memory a lot. Once we destroy a lot of RAM, computer will have nowhere else to put that, and then guess what? Yeah, it's going to have to erase its childhood memories to make more room for these endless copies of the stack. Correction to this bug is, the first correction is, before we copy the stack, we will first delete AHT. And now the code will run in exactly the same way, except we will not see memory leak, but memory leak would be apparent only if we run it, if we did assignment instead of 4 times, if we did this assignment a million of times. We have unfortunately introduced a new bug. So, and in order to see that last bug, I will have one line of code that says dog equals dog. So if I'm assigning from dog to dog, we will see something unfortunate. So we are seeing the error segmentation fault. Let us now look back at the memory diagram and try to understand why is that error happening. If we look back at our original picture, and if we try to assign dog to dog, nobody would ever want to do that, but if we try to do that, unfortunate thing will happen. We will first destroy the stack and then copy that empty stack and that has wrong pointer. So we want to just remove the bug that occurs with this self-assignment. And that bug is avoided by just asking, is it a self-assignment? If address is different from this, then we should proceed with our copy assignment. Otherwise, we should just do nothing, because self-assignment should simply do nothing. Now we have solved the bug. We don't have bug anymore. So this is the end of our video. The next video will show some inefficiencies with this copy assignment, and we will learn how to improve these inefficiencies using move assignment and move constructor. Bye.